let's read the problem together. 122, best time to buy and sell stock 2. Say you have an array for which the ith element is the price of a given stock on day I. Design an algorithm to find the maximum profit. You may complete as many transactions as you like. You may not engage in multiple transactions at the same time. You must sell the stock before you buy again. Okay. So with this, you probably need a linear time algorithm. I mean, maybe you could do n squared. Maybe that's fine too, but I don't even know if that works. And from that, yeah, there is a dynamic programming solution. But one thing that I'm also thinking about is just is maybe like stacks or something like that. Because what you want to do is because you could do something essentially. I want to say greedy, but that's not. I don't know if that's the right word, or I don't know if that's the right classification. But if you just because the way that I try to visualize this and visualize problems in general is like, well, does this relate to an experience that I have in real life or something like that? And in this case, well, how do you make like literally how do you make the most money, right? So you make the most money as you buy and you sell anytime you can. Yeah, and I think that's roughly the idea. And but there may be some nuance to that, obviously. Uh, and I think that a stack allows me to do some weird thing with getting the min of a prefix and stuff like that. But you can also do a dynamic. I mean, I'm familiar with I feel like I'm familiar with the dynamic programming one, but I feel like there's also a easier solution because for an easy, I feel like, and some of this is just meta in general. I feel like for a Yeezy, uh, if a Yeezy problem requires dynamic programming, then I'm probably doing something a little bit wrong, or it's right, but like it's unnecessary. Um, but but yeah, hey Smoker 12345. Look, this matches your user handle. But also welcome to the chat. But yeah, I think there is one additional observation that I would want to say is that because I think I was getting a sense of it, but I wasn't able. I've just been talking about it instead of thinking about it, which is sometimes hard to do at the same time for me. But one thing to note in this case is that let me print out some stuff. Let's say you have 1, 2, 3, 4, 5, right? So yeah, okay. So maybe one way to kind of solve this is like buy on day one, buy and sell them later. Okay, yeah. Oh, cool. Well, welcome. Can I sell the same day I can buy? I guess technically you can. So one way I would model this problem is that so what you want to maybe do and I may have is like okay buy at 1, sell at 2, and then buy at 2, sell at 3, and then so forth, right? So that would give you the ideal solution. And also from that, then you could kind of just, I mean that, and because of some sort of people always use the thing transitive property a lot. I think there's something similar to that here. I don't know if it's quite transitive per se. It's just you can merge these transactions, I guess, if you think about it that way. And as a result, or maybe the reverse is how I want to think about it, is that if okay, the optimal is 1, you buy it at 1 and you sell it at 5, but that is the same as buying at 1, selling at 2, oops, and then 2 selling at 3, 3 selling it at 4, and then 4 selling it at 5, right? And that's the way I would think about it. So you're kind of decomposing it into kind of this stuff. I don't have a downward pointing arrow key, so I'm just going to do something like this. So that's how I would kind of think about it. And then when you think about it like that, and then now in the context of kind of this input, for example, well, you're never going to do this trade because that doesn't make sense. But you want to do this trade, obviously, because that goes to 4. Also, again, you don't want to make this trade because you lose money. But then you could buy at 3 instead of from 3 to 6, and then again, right? So I think that once you kind of type out these examples and visualize it, and a lot of times I will use pen and paper, and when you're in an interview, then use the whiteboard to kind of work out small example cases and illustrate them. But as you kind of do it this way, and because of the decomposition of kind of chains of things, because in theory you could be like, okay, well, here's a 5, let me get the minimum, which is kind of similar to the idea that we have for the best time to the first version of this problem, because that's a mouthful to say. But because of this decomposition, what that means is you only need to look at 2 adjacent numbers, right? And then sum up the profit from that. So actually, yeah, so you can write something like, there's actually a one-liner that I'll do, but I want to write something that is understandable first, and then we'll convert it. But basically now you're doing like, okay, so I'm just going to write it very more readable, but you'll see me optimizing it a bit. But let's say n is equal to prices, and then for I in range of from 0 to n, say. Oh, sorry, from 1 to n. I said the right thing, but I mean I typed the right thing, but I said the wrong thing. So then delta is equal to prices sub I. Is it minus price of I minus 1? So this is the profit, right? This is potential profit for that per day, because the way that we think about it, right? Like we could buy and sell every day that we should, and then if we don't, then if we lose money, then we just kind of go back and say we didn't buy it. So then you have a return value. Let's just call it S for the sum, kind of, and then sum you could just add that to profit or max of profit of 0, so that you get rid of the negative case, and then you just return S, right? That is correct, Quo. Yep. And then I think this should be right-ish. Let's run some test cases. 76431, and then run the example. Oops. The list option. Oh, whoops. I am just being silly. Of course, this is the length of that, and n is an array. That's why I was like, huh? That doesn't make sense. But I just had a typo. Oh, just forgot to press it. Yeah. Okay, so this works, and I would submit it, and this probably works, but and this is very readable. So I mean, relatively, in that like it is what I say it is. But I think the way that I would have tried to do it is in a one-liner. So you could do something like return the sum of max of let's just call it x and y for x, y, and zip of prices. So I have to oops, that's not right. Something like that. I have to double check. No, I think this is for y and x. Okay. So this is what I would end up submitting. So, I think one thing that I need to check maybe is what happens if it's an empty array and one element. So I do want to test those things just in case, because the way I write it maybe is a little weird. Okay, so that looks good. So let's submit, and fingers crossed, hopefully with all the rambling I get it right. Okay, cool. Yeah, so yeah, what is the lesson here? I'm trying to figure out. So this is where, I mean, it is technically, it is a Leetcode easy, I guess that's what I want to say. But it is still like, I feel like it's a little bit, I mean, how long did I end up taking? I mean, I took 10 minutes, but I think I talked a lot. But I think this is still a very tricky problem because it requires some like mathematical familiarity. Like you have to be familiar with like how to like like almost like a feeling about how the numbers interactions together. Um, because I feel like the dynamic program problem solution is actually kind of easier in the sense that like you don't have to worry about the numbers. You just kind of do the like calculate all the possibilities in a way. Where here, like okay, it's technically correct, but can you? But then you have to prove it to yourself a little bit, which is kind of what I did with the decomposition. And because of this decomposition, it allows me to look at only adjacent array elements. But that's still like a leap in logic that unless you have a lot of practice, you may not kind of notice. Um, but yeah, for an interview problem, maybe I would like in a way this is also greedy and maybe a little bit related to Cadane's algorithm, which is also technically dynamic programming. Um, but what would I say on an interview? I mean, I actually know how to do it in dynamic programs, so I would definitely mention that. I don't know if I could prove this in an interview very quickly in an easy way, but I would definitely try to work it out on the whiteboard and kind of just talk about it as much as I can. Maybe get a little bit hints from the interviewer. This is O of n, obviously, and I could have done it with and not much extra space, depending on how the implementation of these iterators. But that's more of a quirk of an implementation. Like if you look at this, it's probably O of n in both space and time. But yeah, I think that's all I have for this problem. For competitive programming, I think it's a little weird and a little tricky, but it's still doable. I think it just like I haven't done this or needing to thinking about this in a bit. And there is something to be said about knowing the first part of the problem properly, that you get a little bit of a sense. Though I don't think I used it that much. But yeah, I think hopefully that answers your question. But yeah, cool.